Okay, welcome to our third video. I swear I'm going to stop like actually counting how many videos we've done. So today we're going to talk about vertical asymptotes. You've seen them, you know about them. You might have sort of a definition about them in your head. I just want to sort of slam down the calculus definition, since we know about limits really well now, and sort of go through how you sort of prove something is a vertical asymptote. So here we have a question. So does f have a vertical asymptote at x equals 3? What about at x equals -1? And so I have in blue there the start of the definition of a vertical asymptote. So we say that the line x equals a is a vertical asymptote. So that's the key term here that we're trying to define, of the curve y equals f of x if one or both of the following things are true here. So if the limit as x approaches a from the left side of f of x is headed to either positive or negative infinity, or, and this is an inclusive order, meaning that it's possible that this and the next thing I'm going to write is true. Both of them can be true. But it's also okay if just one of them is true, that the limit as x approaches a from the right of f of x is headed to positive or negative infinity. So, in other words, if we're thinking about this sort of graphically, if we're looking at the graph of something, and here's a, as we get closer to a from the left, if the graph starts going up like that or going down like that, then that is approaching infinity, one of the infinities, then that's an asymptote. Or going this way or this way as well also counts. And so sometimes we sort of note an asymptote with a dashed line to sort of see that. So you could sort of see like this thing, this expression right here saying, as we get closer to a, either I'm shooting up towards positive infinity or down towards negative infinity. So that's the sort of graphical representation. But we want to sort of leverage these ideas to help us out with this question up here. So let's take a look-see. So what I'm going to do is I'm going to do this claim evidence reasoning style here. So as we usually do, we do not start with the claim. I'll write claim and leave it blank. What we're going to start with is the evidence here. So the evidence is going to be sort of trying out this definition. We're going to sort of take the limit as we head towards 3 or -1 from the left or the right side. So if from the left side it doesn't work out so well, or from the right side it doesn't work out so well. So actually I'm just going to try to find the two-sided limits to see what happens here. So I'm going to start with 3. We're going to try to find the limit. Oh, I'm going to change colors here. So I'm going to find the limit as x approaches 3 of f of x. Okay, and so like I might have to end up thinking about the left-hand and right-hand limits. So if it turns out that 3 is headed to an infinity, that also works. It's just sort of the combination of these two here. Okay, so let's check this out here. I'm going to go ahead and go limit as x approaches 3 of 2x squared plus 2x over x squared minus 2, 3. Okay. You know, like I think it might help to factor this. If it's factorable and there's something to reduce, then that's just going to make it easier to think about. Sometimes you factor it, or sometimes it's not factorable, and it doesn't actually help at all. So let's see what happens here. So this is 2x times x plus 1 in the numerator, and the denominator will factor into x, and we got a 3 into 1. It's going to be -3 and positive 1. Hey, how about that? So x plus 1 divided by x plus 1. So the limit as x approaches 3 of 2x over x minus 3. Oh, well, this isn't helpful. I note that if I plug in 3 right now, I'll get 6 over 0, which is not undefined because we're thinking about a two-sided limit. And so what I want to figure out is, okay, is this does not exist, or is it headed to something else? So I'm going to go ahead and separate this into the two cases. We're going to go the limit as 3 approaches from the left side, and the limit as we approach 3 from the right side. And here's where I'm going to use my number sense to make sense of all of this. So coming from the left side, well, that top is approaching 6. And the bottom, well, if we're on the left side of 3, we're thinking like 2.999-ish type numbers, which means we're going to get a negative number, and it's very close to 0. If we're on the right side of 3, so like 3.0001, that's going to be 6 over like a very small positive number. And so here we got that it's headed to negative infinity, and here we're getting bigger in the positive direction. So it turns out that as we approach 3, we do see this happening here. So I've just now confirmed that at 3, there is a vertical asymptote. The question is there a vertical asymptote at 1 as well? So let's try that out now. So we're going to find the limit as x approaches 1 of f of x. I've already done the grunt work of sort of factoring and dividing, so I don't need to do it again. I'll just actually pick up the simplest limit form that I have here. Oh, this should be -1, sorry, -1. X minus 3, and so now here I get that it's a -2 over -4, so that's a half. And last time I checked, half is not infinity. So since it does not match these, it would appear that we do not have a vertical asymptote at -1. We got something else going on here, though. Like, you'll notice that -1 would lead to the original thing being a 0 over 0. So there's a different type of discontinuity. If you wanted to sort of think about that after the video, like what type of discontinuity is happening there. Okay, so I think I'm ready to fill in my claim. I'll do it in red. We'll do the claim in red. So my claim is that f has a vertical asymptote at x equals 3, but not at x equals -1. Great. And then now let's fill in my reasoning at the bottom here. So for my reasoning, I'm going to restate parts of my claim here and then sort of connect it to the evidence. So f has a vertical asymptote at x equals 3 because the limit as x approaches 3, and here I can choose either to talk about the left side or the right side because both of them head to one of the infinities. I'll just choose the left side. So the limit as we approach from the left is headed to negative infinity. So that satisfies the definition from before. Heading from the left, if it's headed to positive or negative infinity, then you've satisfied it. So boom. F does not have a vertical asymptote at x equals -1 because the limit as x approaches -1 of f of x equals 1/2, which is not equal to a positive or a negative infinity, as is pretty obvious. So there you have it. So if we're ever asked to talk about like trying to prove asymptotes, you want to try to use this definition here. But we don't spend a whole lot of time. But I just wanted to sort of give you another CER in calculus to look at. Please respond to the survey and let me know what you think. And I'll see you guys on the next class, Tuesday or Wednesday. Thank you.